Hey there, welcome to a video discussing section 1.4. That section will be about rewriting formulas and equations. So it's kind of an extension of 1.3, where in 1.3 we're solving for a variable in a linear equation. The equations we have here are not necessarily linear, and actually they're kind of funky equations because a lot of them are geometry based. But what we're going to work on is knowing how to isolate a variable using algebraic techniques. So first off, let's define a formula. A formula is an equation that relates to two or more quantities, usually represented by variables, and some common formulas are given below, like distance equals rate times time, to convert from Celsius to Fahrenheit, or vice versa, area of a triangle, area of a rectangle, perimeter of a rectangle, area of a trapezoid, area of a circle, and of course circumference of a circle. And what each of those letters represent are shown off to the right. So we're going to be working with these formulas today and isolating particular variables. So let's start with number one. Number one, you're told to solve for r in the formula for the circle circumference and find the radius of a circle has a circumference of 32 inches. So the circumference is right here. And if you want to solve for r, what that means is you want to isolate r. That's what we need to do here. Well, how is r being connected to all the other stuff on the right side? Clearly, 2 pi is being multiplied to r. The inverse of multiplication is division. So I'm going to divide both sides by 2 pi. And by doing that, the 2's cancel, the pi's cancel. So what are we stuck with? R equals c over 2 pi. So that solves for r using the circumference of a circle. So r equals the circumference divided by 2 pi. Now you're told to find the radius when the circumference is 32. Okay. So the circumference is 32. And 32 divided by 2 is 16. So the answer is just 16 pi. And of course, don't forget units, 16 over pi inches. It does say to round to 2 decimal places. Let me grab my calculator here. It's kind of good practice just to be comfortable with the calculator. So we'll express it in exact form. So this is called exact form because we're not dealing with any decimals or approximations. So that's what the radius is exactly when the circumference is 32. But if we do 16 divided by pi in the calculator, I do get 5.09 inches. Now, let's look at part B. You're asked to solve for B2 in the form for area of a trapezoid. Well, area of a trapezoid is right there. So A equals 1/2 B1 plus B2 times H. So I'm probably going to multiply both sides by 2 first. Just get rid of the 1/2. And then I'm going to divide by H after that. So notice I multiply both sides by 2. Then I'm going to divide both sides by H. Because when I multiply both sides by 2, the 2's cancel over here. And then when I divide both sides by H, the H's cancel. So what do I got now? 2a over H equals B1 plus B2. Now the last step is pretty darn easy. Subtract B1, and you now have B2 isolated. It's 2a over H minus B1. Now, is this very practical? Not really. Usually when you're dealing with the area of a trapezoid, you're given the bases and the height, and then you just find the area. Or, I guess if you're given the area and have to find one of the dimensions, you plug in the stuff you know, so you start dealing with numbers, and then you just solve for B2. So you don't necessarily have to like isolate B2 with all the other letters put in place. But this is a technique that can be very helpful when you get to more advanced math. Just have to trust me when you get to pre-calculus and calculus or even beyond that. Just the ability to know how to isolate variables when there's other variables involved is a good skill to have, and that's what we're working on here. So B2 is that, 2a over h minus b1. And let's look at C. You're told to solve for w in the formula for the perimeter of a rectangle. The perimeter of a rectangle is 2l plus 2w. This is a little easier than the previous part. So you subtract 2l from both sides and divide by 2 and get p minus 2l all over 2. So that's the width. And then you're told to find the width when the length is 12 and the perimeter is 41. Perimeter is 41, length is 12. You got yourself 17 over 2. Boom, there you go. And oh, don't forget the meters. Don't forget the units if they're given. Um, I am going to be kind of a stickler about that. Again, I've taught a lot of classes. I've taught AP Calculus, and they're pretty strict on showing the units. So yeah, just make sure you show your units. 8.5 meters. Let's look at D. So area of the circle is pi r squared. We want to solve for r, so we got to isolate r. So I'm going to divide by pi. So r squared is a over pi. Then I'm going to have to square root both sides. So r is going to equal the square root of a over pi. Now, technically, you should put plus or minus, but we won't. Why? Well, here's the thing. Radius is never negative. So, of course, I don't want to put a negative. That'd be crazy, right? But in general, when you are square rooting to solve for a variable, like say if x squared equals 4 off to the side, sure, x equals 2, but also equals negative 2. So that's why you have to keep the plus or minus in mind when you're square rooting to solve. That's necessary when square rooting to solve for a variable. But we have an exception for this case because we're doing geometry and a physical dimension can't be negative. But just keep that in mind that when you are square rooting, that the plus or minus most likely will be needed. Okay, let's move on to number 2. We're just going to look at some more just very boring algebra stuff. Here you're asked to solve for y. So I'm going to subtract 9x. Negative 4y equals 7 minus 9x. Divide by negative 4. Okay, there we go. We got y isolated. Then you're told to find what y equals when x equals negative 5. I'm just going to straight up replace x with negative 5. And I get 7 minus negative 14 over negative 4. Okay, 0.1 over negative 4. And you could leave it like that. You don't have to give a decimal if you don't like. If you so desire, we could have actually plugged in negative 5 right from the beginning. And it would have been fine. There would not have been any problems whatsoever. You would have had 52 on this side. And hold on a sec. Something seems a little fishy here. Oh boy. Someone made a mistake. Okay. This is why actually you should check your work. I don't know what the heck is going on with me these days, but I've been doing this mistake lately. 9 times negative 5 is negative 45. I accidentally did 9 plus 5. That's just so weird. So hopefully you notice this mistake I made. Get 26 over negative 2, which is of course negative 15. So actually, sometimes it's not such a bad idea to try 2 different techniques because you should get the same thing. Of course, I didn't, and I caught myself. I'm human. We all make mistakes. But yeah, just be careful. Okay, for number 3. You're asked to solve for y. Now, this is tricky because y occurs twice. So what you want to do is factor out the y. And divide by 2 plus x. And you can do that because y is being multiplied to 2 plus x. So you divide by whatever y is being multiplied to. And then, when x is negative 3, you get negative 6. Okay, this one's a little more challenging. We got like just a few more here and we're done. You can subtract 2x first. So 1 over y equals 1 minus 2x. Now, what I'm going to do is I'm going to multiply both sides by y. I know it seems a little weird because I want to get y by itself. But then I see an opportunity to divide both sides by 1 minus 2x. And that's what y equals. But what we could have done as an alternative solution was that once I was on this side, you do something called raising to the negative 1 power, which you guys haven't learned yet. But it's a fair treatment because you're applying to both sides. But when you raise them to a negative exponent, it flips the fraction over. So now that becomes y, and 1 minus 2x is not a fraction, but if you did make it a fraction, like putting it over 1, you flip it. So that's a total fair treatment. You could do that if you like. But algebraically, I subtracted 2x, multiply both sides by y, then divide both sides by 1 minus 2x. So subtract 2x, divide by y, and then divide by 1 minus 2x. Those would be my steps. And you want to make sure those are legitimate algebraic steps that you're using here. 5 is pretty similar to number 3. Notice that the z occurs twice. What you want to do is collect all terms with z on one side. By doing that, you get xyz minus z equals x plus y. Now let's factor out a z. Z equals x plus y over xy minus 1. So we'll practice those later today or whenever we meet. And then here's how your textbook phrases the directions for similar problems. Solve the equation for y, then find the value of y. Yeah, so anyway, so we just solve for y here. This occurs once. So we move the 3x over and divide by x. So now I got y isolated. Then I'm going to plug in 5 for x. 3 times 5. I'm going to make sure I multiply correctly. Not add those two like I mistakenly did earlier. 15 plus 40 over 5. 55 over 5. And we get 11. Okay, so hopefully seeing this, before we meet again, will kind of give you an idea of what we're going to be doing next time in class. We're going to be doing problems like this, working on these kind of skills. Not terribly exciting, but essential for some of the stuff we do down the road. Okay, so make sure you get to the follow-up questions, and I'll see you guys later.